Hey, Vlog Nation. There. Okay. A special relationship between values. Which values, algebra students? X and Y. Okay. Each input. Okay, and an input is going to be which variable? X. Okay. Has exactly one output, which is Y. Okay. So what this really means, okay, is when you have a function, every single X, okay, has a specific Y. On the flip side of that, you can't ever have two of the same X and them each have different Y values, okay? And that'll make more sense as we move forward. So in a function, you're going to see functions kind of represented. And when I say function, it's just a graph, okay, or some sort of representation of relationships of X values and Y values, okay? So we have, you might see it as a T-chart, okay? If you look down at number 1, that's just a solution set. So that's just a group of points on a graph that you'd be able to make a function out of, okay, or something like that. So for instance, an example of a function would be the point 0.06, the point 5, -2, the point 7, 9, and the point 11, -1. Okay, and I'm just closing those off with brackets. Okay, now the reason that this is a function is because we have 4 different x's, okay, and they all have a y value. Okay, so 4 different x's, they each have a y value. This is a function. Okay, an example of something that would not be a function would be -4, 1, -1, 7, -1, -2, and 5, 6. Please discuss with somebody you're sitting close to why this set of solutions is not a function. I'll give you about 30 seconds. They are on the counter over there. Yes. All right, what do we decide? Yeah. That's exactly right. So, and it's actually one step further than that. So she's exactly right. 2 of them have the same x value, okay? But what may, and that is kind of like your first identifier of, oh, this might not be a function. And what for sure tells us that it's not a function is these right here. They would either both need to be 7 or both need to be -2. But you can't have the same x and then 2 different y values. Okay? That makes it not a function. Okay? Does that make sense? Okay. Okay, so this next section is pretty easy. Okay? You're going to look through 1 through, 1 through 7, 1 through 10, 1 through 13. All of these are different representations of how they might present a function to you. So I kind of want to let's just do an example of each piece, and then I'm going to let you work through these on your own, but these won't take very long. All right, so let's look at number 1. Number 1, we've got 5, -2, 3, -5, 2, -5, 0, -2, -1, -3. Okay, now we have 2 -5s right here, and we also have 2 -2s right here. Is that going to affect us? No, we don't care. Okay, you can double up on y values, and the different graphs that y'all are going to see down the road will make sense as to why you can double up some y values, because you've got lines that will go back and forth across the y-axis. Okay, or anyway, you'll see. So x's, y's were good though, right? They're all different, and they all have a y value. So it would be the answer to this one. Is it a function? Yes or no? Yes. Okay. I'm going to skip 2, 3, and 4. Let's look at 5 through 10 real quick, so we can. And this. So this is another example. Okay. A table, a t-chart. I've heard these called a couple different things. You're doing the same thing though. Okay. So if we look at number 5, what do we think? It is a no. Why is it a no? That's right. These right here. Okay. If you've got two of the same x, they have to match the y value. Okay. Since they don't match, that's a no. Okay. Let's look at 11 through 13. This is the same deal right here. Okay. You just have a group of x values, a group of inputs. Okay. And then you have a group of y values, a group of outputs. They've drawn a line from the x to the corresponding y. So you just need to match them up. Okay. Now, can two different x's have the same y value? Yes, that's fine. Okay. So if we look through number 11, we don't have any of the same x's. They all go to a value on y. So this would be a yes. I would like for you and your partner to just kind of breeze through that front page, complete the rest of that front page, and then we'll get together on the back to do the vertical line test. So you've got 2, 3, and 4, 6 through 10, and then 12 and 13. Now, if y'all are splitting them up, please share when you finish so that everybody's notes are completed. What's up? Yes. So, for which, like, so for number 2, the negative 2 is not considered to be something you need to look at. It's just the other two positive 2's. And so if you have one positive 2 that has a negative 4, one positive 2 that has a 4, those aren't the same. So that's bad. So that's bad. Mm-hmm. So you were saying, is this a function or is this not a function? Mm-hmm. Function in what? Well, so these are all relations because they're in the same group, but they won't all be a function. So what you want to answer is yes, it's a function, or no, it's a function. Okay. Don't forget to share, okay? If y'all split them up, make sure you share your responses. Once you get to the end, we'll check them in just a second. Yep. I saw your name on the A honor roll, so I'm not going to. I'm not going to honor that question with a response.
I really want my 15 pizza.
You still get it? Even after you got threatened with it?
I don't know. I'm not risking it though.
For man, wow. I haven't even thought about that. I need to put my names in. Most of the other teachers have put their names in. I'll have to look at your quarter. I'll go back and look at your quarter. I honestly have not even thought about who I'm going to put.
You still have 2 more quarters that you have to choose out.
What's that?
You're like letting these other teachers have to pick a student out of the entire grade, but you can have like 3 different classes. Yeah. So I feel like yours is easier.
It is easier for picking awards. I would say it's harder to teach because I only get 1 prep period, but for 3 different classes. But that's all right. Okay. All right. Let's check these out. Number two. Number 2 is no. Number 3. No. Number 4. Yes. Number 6.
Yes.
Number 7.
Yes.
Number 8.
No. What? I'm lagging. How is it no? Oh, there's 2 4s. Silly.
Silly Brian. Okay. Number 9.
Yes.
Number 10.
Yes.
Hey, I'm going to put this on the recording too, so there's proof. I said in opening this morning that 8th grade teachers have talked about a handful of you guys and just like the improvements that you've made from just what we heard about from previous grades. You. Yeah, we have.
Oh.
Keep doing what you're doing.
What about me?
You're doing a great job.
I am?
Yes.
Oh.
Keep doing what you're doing.
What about me, Mr. White?
Yeah. Okay. Number 12. I know Brian thinks I'm kidding, but I'm being serious. Okay. Jabron, we've talked about you too. Okay. Ooh, amazing. Oh, the Cocoa Puffs. Okay. Number 13. I put 12 as a no. Do we agree? Okay. Number 13. Yeah, here, I'll show you. So, listen please. So this right here is an input-output thing, okay? So, it's the -1, okay? If you ever have 2 lines coming from one X and they're going to different numbers, then it's got to be a no, okay? Because it's saying it has 2 different outputs, okay? And 13 is a yes. Yes.
My guardian to get a new piercing.
Legally, no.
What about
Illegally, yes.
Well, no one cares about that.
Sorry, I was just kidding, blog. Okay, let's keep going. All right, Brian, sit down. I spoke too soon. Are you? All right. Please go to the back. Vertical line test. As easy as the front page was, this might be easier. Yeah, true story. Okay, so the vertical line test is, for lack of a better group of words, is literally exactly what it says. Okay, it's a test that we use that says if a vertical line intersects a graph more than once, then it is, oh no, it is not a what? There we go, function. Y'all learned this in algebra last year? Oh, good. We tried to. Well, good. This should be even easier. Okay, so what I mean by that? Okay, a vertical line. Vertical is going which direction? Technically up and down. We don't want to say up. Okay, but yes, up and down. Okay, so if this is the graph, okay, and then we'll say this is the line on the graph. Okay, so we've got our xy, we've got our coordinate plane, we have a line graph that's been made, a linear graph. Okay, you will put a vertical line basically anywhere you want on this graph, and as long as it only intersects with the graph that's drawn one time, it is a function. If it intersects more than once, then it is not. Okay, so let me show you what that might look like. So let's say my vertical line, okay, is right here. How many times does it intersect the blue graph? Just once, right here. So that would be a function. Okay, so let me show you what not a function might look like. Not a function. Okay, why? It intersects twice. So let me show you how this matches up with the x and y's thing that we just talked about. I'm going to zoom in. Okay, your x-axis is which one? Yeah, the horizontal one, exactly. Okay, which means our values running in this direction are our x's, right? So if I just take the x value of that vertical line, let's say let's pay attention, please. Let's say that x value is at 2. Okay, so this vertical line is at 2, right? We have a 2 right here at whatever this y value is. Now my colors are all getting messed up. And then we'd have a y value right here. Okay, so we're on the same x, but we have, oh my gosh, but we have 1, 2 different y's. Okay, so that is why when you're just looking at the data, if you have the same x but multiple y's, it can't be a function. This is why when you're looking at the graph, okay, those are related, okay? Not a function because it crosses twice. Okay. So we're going to do some examples. All of these have points, but they do not have a what's the word I'm looking for? A line. Okay, they don't have a line. So what we're looking at is points just kind of placed. Okay, so if we were to connect these in some way, okay, would it pass the vertical line test? Okay, so for this one, I'm just going to connect them however I can. Okay, whatever way is best. So I'm going to go up to this one, over to this one, down to this one, over to this one. Okay, now this very first one is kind of tricky. Would it pass a vertical line test? No, why not? Yeah, that part right there. Okay. So this section right here is a vertical line, right? So it's all going to be encompassed by if you were doing a vertical line test right there. So this would not be a function. Okay, let's look at number 15. I'd probably connect these like so. Would this pass a vertical line test? Basically, you want to start at the beginning of your graph and kind of try and picture it spatially. Okay, just picture if I just move that vertical line kind of across, is there any point where it'd be touching the graph in two spots at the same time? This one is a no to that question, which makes it a yes, it is a function. Okay, the next ones you have are drawn for you. I would like for you and your table partner, or whomever you're working with, to do 16 through 21. And then we are going to move to the next page. And I would be, well, actually, I'm going to wait till the next page. Thank you. All right, are we ready to check them? Why did we say that like it was agonizing? I think we are. All right, number 3. I just said number 3. Sorry, I was in the wrong spot. Number 16. Yes or no? Yes. Okay. Number 17. No. Number 18. No. Number 19. Yes. Number 20. Are we sure? It is no. So the reason being is, let's say, so all a graph is a representation of the data points, right? So this line right here on number 20 doesn't actually exist. But what does exist is maybe this point and this point and this point and this point. Are those all the same x value? Yes, but they all have different y values. So if you see a vertical line, it's an automatic no. You don't even need to do a line test because your vertical line is literally just going to be laid right over the top. All right, so number 21.
It was really fun. It was in a shower.
The exorcism.
Yeah.
Big shower or
My parents' bathroom.
your parents' bathroom shower?
Yeah. Like I turned the water on like really hot and everything started smoking and I put some ghost pepper in there and they started screaming at me.
Yeah, I'm sure they did. Is there a lot of? Never mind. Okay, we're just gonna move on. If I wasn't recording, I might continue. Number 21. Yes or no? Yes. Yes. Okay. Not too bad, right? Okay, we're just gonna do a little bit of practice. On the next page, there's something else I want to show you that I didn't show you on the notes. So here's what I'm going to do. Okay, here's what I'm going to do for this particular worksheet. I'm not actually going to use this as your homework. Okay, these are just some practice problems. We're not going to do all of these. We're not going to do most of these. Okay, the homework is on CUDA, but I do want to kind of walk through all the different pieces of these problems so that you see what you're working with once you actually get to CUDA, because CUDA is going to ask you to do domain and range and function, not a function stuff through a lot of different mediums, I guess is the way that you could say it. So if you would look at number one, okay, number one and number two give you a set of solutions, okay? You need to identify domain and range. You need to identify the X and the Y's, the inputs and the outputs, okay? You're also going to put them in the inputs and output bubbles, okay? And then you are going to graph it and do your vertical line test, okay? There's a lot of stuff with this. Now, here's what I'll say. Is a problem like this, where there's 3 to 4 different tests and pieces that you need to work through, get used to it with algebra, okay? It's not too bad in Algebra 1. I would say even in Algebra 2, okay, you'll get there and you'll do problems like this, but really it's pre-cal. And I would say 90% of y'all will take pre-cal when you're in high school. And in pre-cal, you'll have problems where you're working off one graph and you're answering 9 different questions just on that one graph because you're identifying every piece. And you'll get into holes in the graph, and you'll get into roots, and you'll get into asymptotes, and you'll get into all kinds of stuff. Okay. Asymptotes. An asymptote. An asymptote is an imaginary. An asymptote is like an imaginary hole in the graph that lasts as a line, and a graph cannot cross that asymptote. It can only approach it but never cross it. So, but we'll get there. Yeah. I have lots of pencils. Yep. Okay. So I probably would do my domain and range not first. Okay, you're welcome to. My first thing is to fill out these tables because that just kind of sorts it out for me. So I'm going to take all my X's, okay, and they don't have to be in order of any kind necessarily, but I'm going to put them in these corresponding boxes, and then I'm going to fill in the appropriate Y's also. Okay, then I'm going to place those in my input bubble, which they call this mapping when you're drawing from one bubble to the other. Okay, so the reason that mapping is different than the table is which number did I not need to write twice? 4, right? Because 4 shows up twice in the Y's column. Okay, so I only need to draw it once, but I'll have 2 different X's going to it. So I have -5 going to 4. Okay, I have -4 going to -1. I'm actually going to use a different color. Okay, so I have -5 going to 4. I have -4 going to -1. I have -2 going to +1. I have 0 going to 4, and then I have 1 going to 3. Okay. You can then plot these points on your graph. So I've got, if it will zoom in for me, there we go. So we've got -5, 4, -4, -1, -2, 1, 0, 4, and 1, 3. I would prefer it for you to connect these. It's not necessarily even necessary to answer like, would this be a function or not? But it does kind of help with the representation a little bit. So I would just always connect them as best you can from left to right. Sometimes they'll come out a little janky, but if you draw your graph on the graph, but all your other information is saying that it should be a function, and your graph ends up, I don't know how you'd even do it, but actually, so like if you drew your line like this, okay, that would not be a function because you could double up right here, right? But all your other information to the left says it should be a function, so you just drew your graph wrong. Okay, so like I said, drawing the actual graph is not necessary, but it's nice for just context of what it's supposed to look like. It is necessary for your grade, I guess is what I should say. Now your domain and range. Okay, so we've done some domain and range, but we haven't done it kind of in this context. That's the other thing that the graph can help with, because that is what we're used to going off of. So if we look at the graph, what is our lowest value for x? -5. Okay, -5 is less than or equal to x, which is less than or equal to, what's your highest value for x? 1. Okay, now if you have trouble seeing those, something that I wanted to wait till today to tell you is you can kind of box in your graph a little bit. If you have a closed system, which means I don't have arrows on either side of that line, I can kind of box this in with my low values and my high values. And sometimes it's a little easier to see kind of where the ends and the starts are. Now you don't have to dot them in. You can draw them lightly with pencil, but that can be another way to kind of help you see where the highs and the lows. Okay, as you move forward in algebra, especially algebra 2, you'll call them mins and maxes, but we don't need to for algebra 1. So that's our domain. What's our low value for our range? -1 is less than or equal to y, which is less than or equal to 4. Okay. And how do we get those? Your low value for y is right here. What technique should you use if you're looking at your graph? Pencil scan. Okay. Up and down or left to right. Okay. Any questions on number 1? It's a lot of stuff, but it's not too bad. Okay. The domain and range stuff for problems like this, where you're just given plots on a point. It'll move. Hold on. There we go. I'm not going to make y'all do this. I just want to talk through this last problem. So you can just draw the graph, okay, if you're determining a function. But what information do you need for the domain and the range is the actual values, okay? So for a problem like this, make sure that you can comfortably identify what the points are, the ordered pairs. So I would always start at which point? Yes, let's sound mathier though. The origin, yes, okay, which will almost definitely be on your vocabulary test on Friday. Helpful, Brian. Yes, vocabulary, okay. My answer's been the same to everybody that's been like, what if we can't find one, or how, like, we can't take the dictionary outside of class? Just look them up. Okay, totally fine. In class, I think it's good practice for you to learn how to look stuff up in a dictionary. From what I saw on Monday, it's definitely good that we practice that because a lot of us don't seem to know our alphabet. But after that, now you just need the definitions. You need to know the words. So please just look them up. So we'll start at the origin. We'll go -1, 2, 3, 4, 5, 6, down 1. So that is a -6, -1. We'll go to the left 1, up 3. That's -1, 3. We'll go to the right 2, up 0. That's 2, 0. We'll go to the right 4, down 2. That's 4, -2. And we'll go 1, 2, 3, 4, 5 to the right and 3 up. It's 5, 3. Okay. Now, when you do these, if you are unsure about them, refer back to your notes where we talked about quadrants and what signs each value should have in that quadrant. Okay. So the 5, 3 point should be plus plus because it's in quadrant 1. Okay. The -1, 3 should be negative plus because it's in quadrant 2, so on and so forth. Okay. Then you can write your domain and ranges from here once you have your values. Any questions? Let me make sure this assignment is posted because now that I'm thinking about it, I think I made it, but I don't think I ever put it up. On CudaWorks. Now, part of me saying I try and give you freedom, okay, is you deciding what you need to work on. We have a vocabulary test on Friday. So if you are not done with those, or you need to work on those, or you want to do flashcards for those, or whatever it is, you can do that, and then you can work on this CUDA stuff later on or after you finish. Okay, you still got 30 minutes in here, so you got plenty of good working time. It's like 18 or something like that. No, they're not bad.
I don't think I posted it.
Well, I don't think I sounded like that, but I don't think I posted it. Sound like the kid with glasses from Polar Express.
You know who looks like that kid?
What kind of train is this?
You know who looks like that? Owen Barwood.
Yeah, especially as like a little kid. That's really funny. Okay. Yeah. I was just trying to sign up for it. Don't make it in. I don't. Guinea. I don't. I thought I did.
She said she had to be a new one.
So where do you need to go?
The library. Where should she go because I'm scared? About what?
What's that?
She's gonna be my secretary.
Oh, she's your
Yeah, because I'm registered. Mommy, you think that's funny? It's an emotional support. You're just smile. Can I go with her now? Because you said that. Can I go with her?
Oh, you know what?
What did you ask her? What is she yelling?
If she yells at you, just cry.
She yelled at me. She was very mad at what do we put in for continuous What if my dog
Yes, y equals x of x. So a continuous graph graphs that are connected. The issue is that people will see that they don't work.
Oh, that's so funny.
Maybe next time.
So,
When I get my real one. Yep. So they're giving you the points. You'll have to identify the values of those points, and that'll give you the x's and the y's. Okay. Guys, on some of these questions, it'll say the domains and the ranges, but it's not giving it to you in inequality notation. It's just giving you the list of the x's, the list of the y's. Okay, but you're still identifying the values of the points and then going from there. Yeah. Yeah, that's fine.
I thought I was way later. Yeah, it would be weird. They only teach us like we should be able to pinpoint like where each letter is. But I don't know unless it's JK or element of like.
Well, that's why you practice them.
Yeah, but like no, I feel like it's something we should like know like exactly like.
So I guess my point is that you would if this is something you did all the time, but you don't have to do that. So you don't have to start doing that.
Yeah,
When we had
for school, like I ain't gonna like you know L is this number.
it's more about building. It's just it's learning something new.
Stop!
oh, sure. Shoot it. Hey, you know what? That's my fault.
Alpha is the y. Yes.
I would also like some water, Mr. Bennett. Might I be able to grab some water, please?
I wish you didn't go like this. I don't understand what water.
Mr. Bennett. That's crazy. Don't I'm telling Miss Schultz that you're not very comfortable, that you're not very like safe with throwing
Yeah, there's a box.
I got some water.
Audie, there's a box on the podium right there. Yeah, it's good water.
Stop.
All right, well, I tried. Sorry.
Audie, hurry, the water's not stopping. It's not listening. I command you to stop. Oh my God, just do that. I'm surprised the water didn't get on my building.
Sign up for
What if like you don't need? What if like like for input and output? What if I just know it?
Yeah, that's my preference. Yeah, if you know it, that's great. How much you get on you, Audie? I blame it on Ryan. You said, don't spill it, Mr. Bennett. Like right when the water decided to just explode out of it.